So we are learning now about confidence intervals, and one part of the confidence interval is called the margin of error. So before we actually put together an entire confidence interval, I want to speak to you about the parts, and one of the parts is the margin of error. So again, we can claim with 95% confidence that the interval of p hat plus or minus 2 standard errors contains the true population proportion. The extent of the interval on either side of p hat is called the margin of error. So before, when I was looking at p hat being in the middle and looking at 2 standard errors, this is called, well actually this is called the margin of error. And as you can see, I'm adding and subtracting that to p hat. So what we want to start to learn is essentially that this is the format. The format is my observed value and then how many standard errors. And how many standard errors is called the margin of error. So estimate or observed plus or minus the margin of error is what we're actually computing. Now again, for proportions, we are going to use p hat in the center, and then we're going to use p hat q hat over n square root, which is my standard error. And then there's this new thing, z star, that we'll talk about in just a little bit. But for now, we're just looking at 2 because we're saying it's about 2 standard errors. But again, the more confident that we want to be, so I want to be more sure that I capture the true proportion, notice I can then go out to 99.7% confident. So what happens when I do that? It makes my margin of error wider, which means I'm more confident that the true proportion is here, but also I'm a little bit less precise. This is a fun little comic I found that just is great in terms of margin of error and understanding the balance. This is taking a look at tomorrow's weather. The high temperature will be between 40 below and 200 above. And yay, this guy is never wrong. So this guy has a great big margin of error. It's huge, but we are less precise. So there's no precision here. Yes, it's going to be between 40 below and 200 above, but does that really help me? No. So it's a great comic to show the balance between whether or not you want to be more precise or more confident. Now again, looking at the margin of error, and remember we were looking at p hat plus or minus 2 standard errors for 95% confidence, but the 2 came from the empirical rule, and I've said over and over, hey, the empirical rule isn't precise, it's just an estimation. So using technology, and I'm going to show you how to use the technology in just a little bit, we can find a more exact value for the 95% confidence to use 1.96 instead of 2. So that number that we use is called a critical value, and it looks like z star. So what I will be looking at is instead of using 2, I would use 1.96 if I wanted 95% confidence. Or if I wanted 90% confidence, I'd use 1.645, or 98% confidence, 2.326, or 99% confidence, etc. Now, there is a way to calculate these, because what if I said, hey, I want you to be 92% confident? Well, I didn't give you one of those. Or let's say you've forgotten that all of these exist and you just have to calculate them yourself. So I will show you how to calculate this, but for the normal model, for z's, these numbers won't change, and you'll use these 2 especially all of the time, so it's a good idea to just memorize those 2. So let's take a look in StatCrunch how we will find those critical values. So I'm going to go to Stat, Calculators, Normal, because I'm dealing with the normal model. I'm going to choose Between, and what I want, let's say I'm doing a 90% interval, I'm going to keep the mean of 0 and the standard deviation of 1, and I'm going to replace this number with 0.9, because what I'm telling StatCrunch to do is to make the area between these 2 red endpoints, so all of the area shaded in red, I want that to be 90%. And notice what happened is it gave me negative 1.6449 and positive 1.6449. So typically we're going to use this to 3 places. Don't ever use it to 2 or I'm going to take points off. I'm telling you right now. And again, if I'm only going to worry about the positive, so I'm going to take 1.6449 and round it to 1.645. Now, the only time you get to use 2 values is, let's say I do a 95% interval. Notice it already rounds itself off to 2 values, and so that's okay. But if I did say a 99% interval, I would be using 2.576. So make sure you round correctly. Before we go all in on finding confidence intervals, I want to just focus for a moment on margin of error and some of the calculations that we can do with that. So if you'll recall, we know that a confidence interval is found by taking p hat plus or minus the margin of error. And of course the margin of error is really just our z star, which is our critical value, which we just talked about, and then times our standard error, which is p hat q hat over n. So what I'm doing right now is I'm just focusing on the margin of error. And we're asked to find a margin of error for a 90% confidence level. So 90% should tell me that I'm going to use 1.645 for my critical value. Then it gives me the p hat is 0.4, which means q hat is 1 minus that, or 0.6. And then it also gives me n. So notice all I'm going to do is take all of these values and plug in the 0.4, the 0.6, the 1000, and the 1.645. And then in your calculator, you should be able to just plug all of this in. So I didn't show you any steps in between because I encourage you not to do the steps in between, but just to do all of it in your calculator by entering 1.645 times and then the square root sign, and usually that brings up a parenthesis. Usually I add another parenthesis and do 0.4 times 0.6, close that parenthesis, divided by 1,000. But really, if you just put it in as is, it should be just fine. Just make sure that all of this is inside those parentheses, so you're taking the square root of the whole thing. So I do encourage you to go ahead and find that margin of error and make sure that it is correct in your own calculator so that you know how to enter it into your own calculator. Again, what that tells me is that my margin of error is about 2.5%. Again, looking here, I just moved it 2 places to 2.5%. Typically, I'm just going to keep it in that decimal format. So what I've done is I found the margin of error, and what I want to do now is to calculate the confidence interval. So if they just said margin of error, I would be done right here, and I would probably write a sentence to say what it means. But for now, let's go ahead and look at how we would continue, which is we would have our p hat plus or minus that margin of error. And it's important to understand that the confidence interval always goes from least to greatest, as any interval would. And so even though I've used the plus minus sign here, it's really 0.4 minus and then plus 0.025. So I'm going to subtract the 0.025 and add it, and that's going to give me my my confidence interval, which is 0.375, comma, 0.425, which means all of the values on the number line between 0.375 and 0.425 would be in my interval. So again, just for good practice, let's take a look at some more calculations with margin of error. Let's say I want my margin of error to be 2%, so notice I'm in my margin of error formula replacing margin of error with 2%. I'm remaining 90% confident. That tells me to use 1.645, and it says what must the new sample size be? So they're saying I'm going to adjust my sample size in order to reduce my margin of error, so notice I'm solving for n. So if you're good at algebra, then you should be able to follow these steps very easily to find the solution. If you're not so good at algebra or need a little bit of extra guidance, I'm going to go through that algebra with you. So the first thing I would do on each side is to divide by 1.645 because I want just the square root there all by itself. So now that's what I have on my second step. On my second step, I notice that I've got a square root, and in order to get rid of a square root, I have to square, because those are inverses. So I'm going to square both sides. So that brings me to this step. And on this step, I'm saying, let's see, I want n by itself, so let's take times n on each side. And so on this side, the n's will go away. But I really want n all by itself, so I also have to divide each side by 0.02 over 1.645 squared. And I do that on both sides. Oops, forgot a 0. 1.645 squared. And that's where I get this. So n is by itself. And notice again, you might be saying, well, why did you deal with all those fractions and the craziness all through this? Well, because if I would have taken this and rounded it and taken this and rounded it, then I'm just going to end up again with an imprecise answer. So make it precise all the way to the end, then plug this into the calculator to get your final solution. My final solution is 1623.615, which means my new sample size would have to be 1,624 to reduce the margin of error to 2%. So here's another margin of error question. Again, I just wanted to give you one of each. So this one says, what level of confidence? So now we are trying to determine the level of confidence, which means essentially we're solving for z star and then using z star to figure out the level of confidence. It says, what level of confidence was used if the margin of error was increased to 3.6%, still using p of 0.4 n of 1,000. So notice all I've done is I've replaced the margin of error with 0.036, and my z star is my unknown. So now I'm going to just do the math, and the math says, hey, get z star by itself, which means I have to divide each side by all of this, and so that is what I've done. On my next step here is I have z star is equal to all of this. Again, plug that into my calculator just as it is, and I get 2.324. Now, what I need to do then is to find the level of confidence, because I haven't found that yet. So I'm not going to actually go into StatCrunch, but I'm just going to explain how I found this. Again, I went to the between function of the normal calculator, so stat calculator's normal, click on between, and notice what I did is I replaced the two values here with my negative critical value because I found the positive, but I replaced it with the negative and the positive, 2.324 and negative 2.324, and this is the answer that came out, which means between these two bars is 98% exactly, or not exactly, about 98%. So I would say that I likely used a 98% level of confidence. So here's one more calculation for you to try with margin of error. This one will not require StatCrunch. This one says 2 people are running for an office. What sample size does it take to estimate the outcome of an election with a margin of error of 3% and 95% confidence? So you might be saying, well, what's p hat? Well, we don't know who's going to win, but if there are 2 people running for office, at best it's 50-50, right? Or I guess at worst it's 50-50. At best we know a little bit more information and can say with a little more certainty. But for now, let's just assume p hat is 0.5. I want you to tell me what sample size. So solve for n. So press pause, try this question, then press play to see how you did. So again, I'm using my margin of error formula. I've put 0.03 for my margin of error. I've used 1.96 because it says 95% confidence, and that is the z star for 95% confidence is 1.96. And for that, again, you can use StatCrunch, or you can just memorize that that's the z star, the critical value for a 95% confidence interval. And then again, I'm just doing the same algebra that we did before. I'm dividing each side by 1.96 to get to this point. I'm squaring each side then, and then I'm dividing each side by the squared value. and I get 1067.11. Notice because it's a person, I've rounded up, and that's pretty standard practice is to round up when it's people.